What's up, everyone? This is Ryan here, and you are watching episode 18 of my Android developer Q&A. So we've got a fun episode planned today, and so basically what happened is last week I was just so wrapped up with A, life, and B, the room database tutorial, which I'll talk about in a little bit, that I didn't have time to prepare a proper lesson for the final part in my 5-part series on the solid architecture principles. So what we're going to do is today we will cover the final part of that, which is the dependency inversion principle, and we'll run through an example on that, and then we'll just get straight into Q&A after that. But before we get there, just a couple of things. So for starters, just wanted to say thank you to my wonderful patrons. So supporting today's show, we have Tony Jones Jr., Trevor Halvorsen, Basam Halal, Nanotech, Shadow, Mr. Bidwell, Sushil Chanda, and Elad Stavi. So thank you to all those people for supporting me on Patreon. If you're interested in supporting me, or if you like what I do and want to support the show and all that stuff, then you can either do me a favor, hit the like button down below, or you can check out my Patreon page if you'd like to support me that way. And if not, that's fine too. So yeah, let's just get to our one announcement for today. So unfortunately, this project ended up being about 3 weeks sort of later than I really wanted to release it, and I ran into a couple different difficulties with it on top of just life being somewhat difficult just in between all that stuff. But I now have uploaded finally my Let's Build a Room Database app tutorial. So I'm not sure if I have the link down below, but there's probably a link to the repository. And basically in that tutorial what I do is I build an entire basic room database app. It's very simple, but what it'll do is it'll show you the basics of getting started with room persistence library, view model from the Android architecture components, as well as live data from that as well. And it'll show you how to build all of that stuff in the context of a model view model architecture. And yeah, there's a couple different things. There is a really basic implementation of Dagger 2 in it, although I kept that very, very simple because the thing about that tutorial, part of the reason why it was so long is just there was so many different APIs to explain that it kind of got difficult to sort of work that into a single video. Like the video ended up being almost 2 hours long. I think it was like an hour and 43 minutes or something, but yeah, super happy to have that done. Now I will be adding a part 3 to it eventually, because the one thing I just did not have time to do was add in data binding, and when I do decide to do that part 3, I might also add something else, and I might try and improve the Dagger 2 stuff or something like that. But suffice it to say, I have many other projects which are a lot higher on the priority list than part 3 of that tutorial. So all I really wanted to do was just be like, okay, here's how to build the basic room database tutorial, and here's kind of how you want to structure the software architecture, and that's pretty much all I wanted to cover there, because there's only so much I can cover in a video. Excuse me. Anyways, so that's it for the announcements. Go check that tutorial out if you're curious about room database, and also there's a full open source repository, so you can steal the code, play with it, do really whatever you want with it, except for pass it off as my stuff. So yeah, that's basically that. And then let's get into our, hey, good morning. We've got Omar and I joining me already, and yeah, thank you. So what we're going to do is we're going to talk about the dependency inversion principle, which is, as I mentioned before, the last part of the, let's see here, the last part of the solid architecture principle. So we've been through the single responsibility principle, the open closed principle, the Liskov substitution principle, the interface segregation principle, and then now we're on the dependency inversion principle. Now, I have to be honest, I have what is in some ways a limitation and some ways kind of a cool thing, which is that I really don't have an easy time understanding these principles based upon these kinds of definitions. Now, I'm not saying that these definitions are bad, I'm saying I have trouble understanding them. So instead of talking about this stuff really verbally, which I've seen a lot of people do, and I don't really learn anything from that myself, what I will do is I want to show you sort of the first time, as sort of a personal experience, this will be the first time that I sort of started to see, and this is true, I'm not just making this up, this is one of the first times that I started to see how the way you structure your application can solve enormous problems before they even become problems. And what I mean by that is, well, let's get into the demo. So before we get to the demo, I'll give you the sort of the standard verbal definition or technical definition of the dependency inversion principle, and then I'm basically going to leave that and hope that I basically explain this, but just by example, because so what we're looking at here is so there's two parts to this. A, high-level modules should not depend on low-level modules. Both should depend on abstractions. So again, this is a little bit difficult because like it's not immediately evident to me what exactly a high-level module is or a low-level module, but the way I think about it is I would say like a high-level module might be something like, let's say we're building just a 3-layer architecture. Let's pick a really simple example: model, view, controller. So in this case, I would think of each of those as high-level modules. And why are they high-level? Because we're not very specific. We're not worried about finer details. The view draws things on the screen and relays stuff to the, sorry, did I say presenter? Sorry. The view draws stuff on the screen, relays stuff to the controller. The controller sort of communicates and makes logical decisions between the other two layers. And then the model is responsible for sort of data, structured data management and access and storage and things of that nature. So that's what I would think of as a high-level module. Versus a low-level module, I would assume would be something like a service class that would fit inside one of these things, but I'm not entirely sure. It's, yeah, I have trouble with stuff like that. But the second part is that they should both depend upon abstractions. Now, in doing research in the dependency inversion principle, one thing I learned is that so this is something I assumed at first, but I assumed an abstraction meant specifically like an interface or an abstract class in Java. That's not, apparently, that's not really what is meant, and that's kind of where we'll get into the interesting example stuff. As for the second part, B, abstractions should not depend on details. Details should depend on abstractions. Again, I think what they're saying there is basically, well, let's get into the demo and I'll try and revisit that, but chances are I'll probably forget. But my hope is that when we go through this example, you will see in code and in the architecture why this stuff helps, because we're going to be solving a problem by changing our software architecture. So let's get into the code. So what I'm going to do is we're going to look at two different sort of sample problems and sort of sample data structures, and we'll see sort of, I hope we'll see where this thing sort of starts to make sense. And first I'm just going to move this over to the other side. Move to right. Perfect. All right. So let's first look at, so this is what I would kind of call a bad solution, and we'll understand why it's bad later on. But what I'm going to do is I'm going to open up these three classes and we're going to talk about them a little bit. So our three classes are basically, so I want you to sort of assume we're building like some kind of 3-layer application. This thing could be called Note Controller, it could be called Note Presenter, it could basically even be called Note view model, although it wouldn't actually really talk back directly to a view, which the thing is, this is pseudocode. This is not supposed to be like a really concrete example, but I just want you to keep in mind, you could apply this in any of the three major architectures. It really isn't architecture specific here. So let's just briefly talk about our first class here. So just in a nutshell, we're just going to go with model view presenter. That's what I'm comfortable with. And what a presenter does more or less is that it talks to the two different, it'll talk to the view, and it'll kind of both handle the input from the view, and it'll tell the view what to do. The view is kept pretty dumb. So that's basically its responsibilities. So in our first example here, what we have is we have this thing called note presenter. And the big thing that we need to do here, and this is our challenge for today, is we need to save data to both a local and a remote repository or database or whatever. So just in simple English, we want our data to be saved on a device and also in the cloud, which I hate that term because the cloud just means someone else's computer. So it's either going to be on your device or someone else's computer. So that is our problem. And the way that we've chosen to solve it first is we've created this note presenter, and of course it's going to need to be talking to some kind of data manager thing. And in my first solution, what I've done is I've said, okay, well, obviously I need a note database. Now there's no implementation in these examples because it's beside the point. But let's say this could be like a realm database. It could be a room database. It's something local. We also have a sort of a remote data store, and that would work through some kind of network service. Again, there's no implementation, but if you want, you could think this could be retrofit, it could be volley, some kind of REST communication API. And so basically what these things do is that we're going to just pretend that this thing only has to do one thing. And basically what happens is at some point, the view, doesn't matter what it is, a fragment activity, I don't care. Some view says to this presenter, hey, the enter button was clicked and here's the user input. So let's imagine it's a note-taking app. The user inputs their note, hits the check mark, and then the view says, here's the input. So in our first solution, what we're doing is we're taking this user input, of course, from the view, and then within our presenter, we are saying directly to these two sort of concrete classes, and by concrete I mean they're not interfaces, more specifically. We're saying to these two things, hey, note database, save it. Or note network, oh great, we got the garbage truck outside, my old friend the garbage truck. I feel like Elliot Hulse anyways, but random tangent. So we basically just say, hey, save note on these two different services. So as a beginner programmer, you might sort of type out code like this, give yourself a pat on the back, crack a Mountain Dew and slam it, and you're done for the day. But it turns out that this is actually a pretty crappy way to solve this problem. And let's talk about why. And this is where things start to get a little bit more technical. So there's two immediate issues that we need to talk about here. And those primarily have to do with responsibilities. So what is our presenter supposed to do? It's supposed to take input from the view, make decisions about that input, call whatever service, the data service it needs, or the repository or whatever, and then sort of, if it needs to, call back to the view. But it should make decisions, and that's basically it. It's kind of like passing stuff around, I kind of think of it like. So that's its sole responsibility. Now, in this first example, we have two primary issues with this. And this is where we start to get into sort of the high-level stuff. So our high-level module, or our high-level class here, which is the note presenter, I want you to take note, excuse the repetition, that it knows very intimate sort of details. It knows specific details about the sort of the data side of the application. So what I mean by that is it depends directly on our two services. So we'll see why that's kind of an issue in a moment, but I just want you to take note of that. This note presenter depends, as in it holds reference to two different services, and these two services do exactly the same thing. Their implementation is different, but conceptually, all that they do is they save a note, which if I'm not mistaken, that is the abstraction we're talking about. Not an abstract class per se, but the abstraction of the presenter, or sorry, the abstraction of the data layer is sort of that its job is save note. And instead but now we have a case where the presenter A knows that we have two different services and just knows more details than it really needs to. And the last thing I'll harp about in our crappy example is that the note presenter creates these things. So when the note presenter is created, we create our two database services and we assign them. Now this is problematic simply because we have added an extra responsibility to the presenter, which, sorry, I'm like a Nazi about typing, which is the creation of its own dependencies. There we go. And that is a responsibility. Object creation is a separate thing. So we're kind of our presenter, and this is what we'll leave on with this crappy example. Our presenter knows more than it really should, and we'll see what I'm talking about there in a moment, about what's going on in the data module of the application. It knows like intimate details and it knows concrete classes. That's an issue. Secondly, because we didn't use any kind of dependency injection, it now has the extra responsibility of creating its own crap, which breaks the single responsibility principle, which we talked about in the beginning of Solid. So this is kind of a crappy solution, and this is probably something I would have seen in my old code, basically. And what we're doing is we're saying, okay, we need this presenter. Okay, I know that it needs a local and a remote data source. Let's just plug them into the presenter. The presenter will talk to them, whatever. That's a crappy solution. Let's talk about a better solution, which, if I'm not mistaken, applies the dependency inversion principle. But whatever, let's leave the words aside, and I will just show you how we can just build a better architecture, and hopefully it sort of coincides with the whole big words thing. All right, so in our second example, we've changed a number of things. I really wish I could zoom in on this side panel, but I have not yet figured out if I can. It doesn't appear I can increase the font size over here. But just really briefly, we've divided things into separate packages. In our first example, we just had this note database, note network service, note presenter. Everything's in one package. Everything depends, is tightly coupled, blah, blah, blah. In our second example, we have a package for the presenter. We have a package for the repository. Let's ignore this inject thing. It's just so that I can write inject here, but it's not actually Dagger 2. And when I open the presenter, all we have in there is the presenter. And when I open the repository, boom, all of a sudden we have like this little class explosion going on here. So we've got this note object, which is just the Pojo. It's not really relevant. It's just basically a string. And what I've chosen to do in this case is I've said, okay, and this is where things get interesting. So, as I mentioned before, at the higher level of things, this presenter is concerned about talking to our data module and the view. It should not be concerned with how the data module works at finer detail. It should just, at the highest level, it should just know, I want to be able to call something that saves data, and that's all I want to worry about. So, as opposed to depending upon concrete classes. Instead, what we're doing here is we've created this note repository object here. Now, that should actually be note data source. Sorry about that. That should actually be note data source. I apologize about this, screwing up my own. So instead what we're doing is we are actually depending upon an interface. Let's have a quick look at that interface. So all this interface does, and I want you to think of this as like a very high level sort of abstraction thing, is we're basically creating this contract that says whatever implementation or concrete class that implements this thing must be able to save notes. And this is what our presenter will be depending upon. It's not going to care if it's a local repository, a remote repository. It's not going to need to know or worry about any of that stuff, and it shouldn't. Now, what we're going to do instead is we're going to, so there's two things. Number one, we're now depending upon an interface. So that means that we can basically mix and match whatever we want behind the interface as long as it implements the contract. So we'll see how that benefits us in a moment. But a second thing we've done, and I'm not going to talk a ton about Dagger 2 here, but we've also used a dependency injection framework. So in this case, I've mocked Dagger 2 with an inject annotation. But basically, in a nutshell, let me explain dependency injection in like a minute. So if it's not dependency injection, this presenter creates its own dependencies. That's it. Like the previous example, new data repository, whatever it's called. That's not dependency injection. In this example, some other thing, a framework in this case, Dagger 2, creates the repository and gives it to the presenter. That is dependency injection in like a minute. It's honestly dependency injection itself. It is like, it's a concept that a child could understand. Dagger 2 is not something a child could understand, but we won't get into that. So we've done two things. We've basically fixed our presenter so that it really does only have the one broad responsibility, but it's not worrying about creating its own stuff, and that's the first sort of issue I wanted to talk about. And the second thing is, let's have a look at our data source, because things have changed a little bit. So as you probably notice here, we're just calling one data source. We're saying note data source.save note. Now, as I mentioned before, our primary problem here is to save to both a local and a remote repository. So if you're a beginner or you're not familiar with this stuff, you might be wondering, like, well, what's going on here? Like, there's only one class here. Let's open up the note repository. So this is kind of a facade pattern going on here. I've heard it called the repository pattern. If you want to sort of Google that further, facade, F-A-C-A-D-E. I believe it is a French word. So let's open up the repository. So I want you to notice two things. For starters, we've created this new layer, this new class called the repository. Now, our note presenter doesn't even know about it. Like, yeah, it gets passed in here, but we could pass an interface in, but that doesn't really matter. This thing gets, after the constructor executes, this thing is, what do you call that, not instance variable. I don't know, I forget all those stupid names, but it's going to know this thing through the interface, and it's not going to know even that it's the note repository. It's just going to know, and what I mean I mean the presenter, that it's talking to some class that implements this contract. So now we've created this note repository which implements note data source, and of course it's overridden the method of note data source. So we pass this note in, and now we have a data layer, sort of a high-level data module, which implements the interface, which has the responsibility of managing saving data. And that makes a lot more sense. This thing can have finer details about what it needs to do. So in this case, we have the note database, local storage, and the note network service, remote storage. And so we pass our note in, and then this thing is now responsible for this stuff. Now, if you're wondering, like, we wouldn't actually write it like this in a real app. You'd probably want to use RxJava so that you have callbacks, or you'd want to do this asynchronously, but this is just pseudocode. And then what we do is we actually have our note database and our note network service implement the contract as well. And so now we have a situation where our note database, everything implements the same contract. Again, there's no implementation, but this thing would be a realm database or room database. It would save the note, call back, and then basically the same thing with the note network service. It could be like an API. And so that's kind of that. So now our thing that needs to know more details about how the data source implementation will work knows that. We've taken that out of the presenter. So that's done a couple of things. For starters, it's simplified our presenter drastically. And when we simplify it, that does two things. It makes it easier to test, and it makes it easier to read. It's also just, it's good practice. And then we've created this extra class, which we've offloaded those responsibilities to. And then this thing can sort of worry about all the finer details of managing the data. So that is basically, in a nutshell, what's going on here. Now, to wrap things up, I want to talk about what we're actually doing here. So as opposed to designing our classes right from the get-go, tightly coupled, which means like we've got our presenter, which depends directly on two concrete classes, which makes it harder to test and harder to swap things out. Let's say we swap out for a different API, then we've got an issue, because not only will we have to change that API itself, but we'll also have to change the presenter, which is stupid. If you're making changes in the model, that shouldn't affect the presenter. If you find yourself changing things on one end of the app and that change needs to be propagated across the other layers, the implementation needs to change, that's a big hint that you need to restructure things. You need to be depending upon interfaces, and you need to do the whole dependency inversion thing. Mainly like depend upon interfaces. Holy crap, it's like 30 friggin' degrees in my room right now. So anyways, hopefully I've done a relatively decent job of explaining how to, indirectly the dependency inversion principle. We've sort of inverted things so that our modules are depending or inheriting from interfaces. So we're basically having them communicate through like high-level communication lanes instead of like finer details. And then sort of as things get more complex, we create sort of finer and finer modules or parts of the app which have more and more detail about what's going on. Like for example, if I go back to our note repository here, the note repository doesn't even need to know, like we could even sort of write this as an interface, but this repository doesn't need to know what kind of database, it doesn't need to know what kind of remote service, but it knows that it's got those two things, and it rightly has the responsibility of delegating the data to those different services. So this was sort of the first example. This sort of repository pattern was the first time I ever sort of saw software architecture and thought, holy crap, because the thing about it was when I was building Profiler, I was running into all these different difficulties with testing and complexity. And when I started to see that I could kind of pull things out, yes, we get more classes, but that's not actually a bad thing. Like in many cases, you'll be writing less lines of code because each part has fewer implementation details, which is less lines of code. Yeah, you have to make more classes, but just consider that. we sort of almost like stretch this architecture out into like more and more to like high level sort of abstractions and responsibilities into like concrete details and implementation and as necessary. And our dependencies sort of travel in that direction. We've got high level stuff depending on abstractions and interfaces, and then our lower and lower level stuff sort of implements those interfaces, and everything works well together. We can swap things out, we can mock things easily in tests, and it's easy to read. So that is my explanation on the dependency inversion principle. I really hope I did a good job on that, and yeah, let's take a quick commercial break and wipe the sweat off my forehead, and let's get into some Q&A. Holy crap, it's warm in here. All right. So, if you've enjoyed the show so far, please do me a favor and hit the like button down below, and consider turning off your ad blocker. Oh. All right. Got a couple people joining us. What's up, Daryl? We got the Vladan. Vladan, he's joined us again. And you are very welcome. Vladan was just dropped by to say thank you for the model view model and room stuff. And yeah, no worries, man. Hopefully it helps you. Okay, so I've got a quick question by Tamir, and unfortunately I'm really not the person to ask about it because I am an Android developer, and I haven't really branched out from there. But the question is, Tamir wants to develop an app for both iOS and Android, and he's very overwhelmed about all of the options out there. Could I talk a little bit about native dev versus Xamarin and React Native? And you know, the thing about that is I can't give you a good answer on that, but I'll try and give you a couple thoughts, and they might be somewhat useful. One moment, I'll just write the question out. So I'm going to paraphrase your question a little bit here, but if you want to develop apps for iOS and Android, how should you go about doing that? And well, there's our first voice crack for the day. So yeah, the question is, if you want to develop apps for iOS and Android, how should you go about doing that? So let me tell you what I would do, and this would be my approach, and you have to understand that I don't think I'm going to give you very good information because I don't personally have the experience. Like, I've written a little bit of Swift code, and I've made like a calculator in Swift, but I'm not well versed in it, but there might be a few thoughts I can share. So for starters, the way I would go about doing it is two things. I don't really know about how easy and functional it is to work with React.js, I believe it's called, which is basically, if I'm not mistaken, how React kind of works is within JavaScript, you can write your application for Android or iOS in the same language. And if I'm not mistaken, it's probably done through like web views or something, but I could be totally off base there, but it's JavaScript based. So that's the first thing. So there's two things that you'd have to consider. What are you going to gain and lose by doing that? On one hand, yes, you are only working with one single language, and that has benefits and deficits. So on the benefits side, you only have to learn one language. On the deficit side, There are things that are easier and better to do on iOS in Swift or Objective-C, or on Android in Java or Kotlin, that are better, because different languages are better at different things. So that's just kind of a basic fact. So that's the first thing I would mention. I personally would actually learn the language for the operating system. That's how I would go about doing it, and I do plan to learn Swift eventually. So that being said, I would also like to learn JavaScript for web development, and I would like to branch out, because in my personal opinion, that is a question you need to answer by learning the actual stuff and just diving in and seeing what kind of works. Now that's a huge task, because you're setting out to learn several languages. So for me, I'm not really intimidated by that, because I'm in it for the long haul, and I'm happy to learn several languages. But if you just want to make a quick app which works on web and iOS and Android, probably you're going to want to just learn the React.js approach. As far as Xamarin is concerned, I anecdotally, don't take my word for this, but I have heard that it's not ideal for Android, but what that actually means, I don't know, so ignore me on that. The last thing I'll talk about, and this is one little hint, and this is something I've thought extensively about, is if at all possible, another thing you can do to sort of ease the difficulty of working with this stuff is you could do something like, let's say you've got your basic iOS app and your basic Android app, and you want to build like the model, the data storage part of it, or the back end. What you can do in that case is you can take advantage of services like Realm or Firebase. You can take advantage of those services so that you may have to write different apps, different front ends in iOS and Swift and Java and or Kotlin and all that stuff. So yeah, you might have to write the front end like that, but that's fairly simple. If you're depending upon a service which is cross-platform compatible, then you're already saving yourself an enormous amount of time, because then you don't have to bother about learning all the content provider and all the sort of Android specific stuff, and I don't even know what it is on iOS, but hopefully you understand what I mean. So that's basically my thoughts on that. Probably not especially useful, but those are my thoughts anyways. So, be super great if we could get some questions going here. Otherwise, I'll have to just start going through the room database tutorial. Okay, so we do it. Oh, awesome. I'm glad my answer helped, Tamir. I didn't think it would. So Syntech asks how to use room database with content provider and resolver. And honestly, my answer to that is that I don't actually use content provider or resolver, so I can't give you a good answer on that. To be honest, the way I structure my applications, I've never seen a use for them. Like, as far as I'm aware, the only time when in my application, I would sort of need to use a content provider is if I wanted to expose data to other parts or other applications on the device, and I haven't actually run into a use case where I need to do that. All I really know about content provider is that it's sort of like it's like a data access mechanism, but how you would wire that into a room database and when you would need to, I don't have personal experience with that, so I can't really help you. Not a great answer there, but it's my answer nonetheless. That's a quick question I can answer here. If there are beginners listening, like if you want to ask just general questions, what? I don't really understand. Syntech asks, how do you share a database between databases? Oh, two apps. Okay, I'll get to that next. But a quick question. Okay, I can explain how to do that. Just really quick question. Let's see. Android and Java asks, how long would it take I think what you're asking, I'm paraphrasing a bit, is how long would it take to, say, for example, I think what you're asking is, let's say you're already good with Java/Android, like you have the basics. How long would it take? Am I in full view? No. How long would it take to learn Swift, for example? So that's kind of an interesting thing. So I would sort of think about this in two ways. So number one, obviously it depends on how far you are in your own sort of setup. Now here's the thing, and in my case, I do not think it would take very long at all for me to learn Swift and be building decent applications within about, well, medium scale applications within about 3 months for me. Now, the reason I say that is when you first learn a language and you have no programming experience, you're dealing with two big tasks. A, you're learning the language, which is not trivial. For me, I had a really hard time learning Java at first because I'm a super visual thinker, and almost everyone explains it verbally or in like really bland slides with boxes, and just it didn't make any sense to me because I couldn't think about it. Anyways, random tangent. But so you have to learn the language, which I think with decent practice you can master the you can cover the fundamentals of a language, I would say, in 2 or 3 months if you work at it. Maybe 1 if you have a lot of time to work on it, but as a beginner, it'll probably, if you work regularly, it'll take you about maybe 3 months before you're comfortable. But that depends on who you are, your learning speeds, your learning resources, all that stuff. So the thing is, though, there's a second problem, and this is what I ran into. Because first you're learning the language and your framework, like Android and Java. But then, and this is the stuff which I wish someone had taught me about earlier, because there was about 2 years where I had no idea what I was doing, and that's software architecture. How do you actually build apps? Now, the thing is, the reason why I don't think it would take me long to be able to program decent apps in Swift is that I don't care what language it is. I know how to build model view presenter applications, model view controller applications, model view view model applications now. I know the patterns, I know the software architecture, so that whole piece of learning is already very familiar. Obviously, things would be arranged differently a little bit, and maybe I would assume that probably Swift and iOS are kind of Nazis, for lack of a better term, or I could be totally wrong, but I would assume they probably like to do things their way, knowing Apple, but I don't know that firsthand. But once you've sort of mastered one framework and one language, it becomes a lot easier because you don't have to go through the whole software architecture learning thing. All of these different commands are basically just worded differently, so you don't have to figure out, okay, what is a loop? Because if you know what a loop is in Java, you know what a loop is in Swift. It just is written differently. So I would say, to sort of wrap the question up, how long would it take if you're decent with Java to learn Swift and you're already comfortable with software architecture and object-oriented programming principles? I would say maybe 3 to 6 months. So it's kind of a vague answer. Okay, what else have we got here? What's up, Ronald? So, oh darn, Daryl already answered the question, but I'll just mention it briefly. Mon ami Daryl. All right. So, so this is another. This is going to be just a quick one. I'm not going to go into deep detail because I'd like to get to other questions. But Syntech asks how to share a database between different apps and platforms, presumably. I think that's what you're asking. I mean, so between apps on the Android platform, you would use the content provider, but here's what I would kind of suggest. So let's say you, for example, you have an iOS app and an Android app and a web app, and you would like to share the data, excuse me, you would like to share that data between all of these different applications. You want to share the same, you want a central data repository that all three kinds, iOS, web, and Android, talk to. All of them talk to one spot, one data store. In that case, you basically have two choices, or two simple solutions. Number one is use Firebase, or I forget the big long technical name of those things, but a back-end service like Firebase. So what you can do with Firebase is Firebase allows you to create a central data sort of cloud storage repository, and then you can configure your iOS app, all your different kinds of apps, with the same key. And so when you've got that set up, you have all your things talking to this Firebase app through the same, or to the same database with access to the same database, pretty much. Now, there's kind of two ways you can go about doing that. Firebase has its APIs for Android, which you can use. So you could like directly use the Firebase real-time database API, or I'm sure they have something equivalent on iOS. Or Firebase is also set up with REST, RESTful architecture. So you could have like REST adapters for each kind of app talking to the Firebase. Whatever you kind of prefer there. I personally would like to move towards using REST, but the last time I used Firebase, I did just use the Android API for it. But in that particular case, you have one Firebase project and multiple apps within that project, and that would be a great way to do all that stuff. Now, and generally speaking, especially if you're not a senior Android developer or you're pretty damn good, as this is something Daryl mentioned, you're probably going to want to take that route. And the reason why is that you can build your own database. Like you could build your own server and manage it that way. But the thing about that is that's a very complex process specifically to do with security. So if you're handling sensitive user information and you're building your own home-baked sort of server, and you're not like using authentication tokens through Facebook and Google logins and stuff like that, all that fun stuff that Firebase gives you for free, then you're getting into deep territory. So for beginners or intermediates or anyone who's not super clear on how complicated the security side of things is, I would strongly suggest Firebase or something similar. Maybe Amazon might also have a comparable thing, but I haven't actually worked with it. Anyways, I'm just going to take another quick commercial break. If you've liked the show so far and you haven't already, please do me a favor and hit the like button down below. Holy crap, it's still really warm in here. Oof. All right. So this is just a quick one, really quickly. Kareem is asking, his app is slow with a list of images in Android. How can he make it faster? So I'm going to assume you're not using an image loading library. So you're going to want to either use Glide. I'll just write the names down here. To speed up image loading / processing, use either Glide or Picasso. I think Glide is a little bit better at this point in general, but they're both really simple, awesome APIs. And I'll see if I can pull a code sample really quick. Do I have it in room demo? Just give me one moment here. I can't remember which apps I use which APIs super well. Yeah, I might not actually use Glide in this one. Do I use it? I might use Picasso in Pause Trainer. I'm not entirely sure. What project do I have that uses this crap? Okay, give me 1 minute. I'll pull up. I can't share the whole repository with you, but I'll share just a code snippet. Just let me pull it up on GitHub. Where is it? Here we go. One moment. So that would be the list. Yes. Okay, so for example, I'm just going to block some of this out here. So here we go. So so this is just a really quick example. So this is how Picasso works. So let's say this is part of a recycler view. This is the on-bind view holder of a recycler view, which displays a series of fairly high resolution images. And so what you do with Picasso, for example, is you say Picasso.width and you give it a context object. You can actually give it, I think either way it ends up grabbing application context. And then you say load, so you can load either an image URL or you can load a image resource or kind of whatever you want. I think you can also load a bitmap. And then you say into, and I love this API. Like, it's so simple. Load into. Like, this is beautiful code. Load into. It, like, you can understand that instantly. So load into this image view. I believe that, yeah, it's just an image view. And so the thing about that, so obviously, like, you've barely done anything. And I'll just close this out now. So with Picasso, for example, and Glide is very similar. They're both great APIs. You just do that, and it's automatically going to sort of scale. There are different what do you call those? Operators, maybe, I'm not sure. There are extra little methods you can do to like scale things down even more. Check out the documentation is, the main, what I would suggest. But use one of those libraries and they'll allow you to load images quickly, and they do so much stuff in the back end that helps you avoid memory leaks and all kinds of crap like that. So that'd be my suggestion to speed up image loading. Use either Glide or Picasso. And did I write them? I did, yes. Okay. So what else have we got here? Probably only going to do one more question here. Gertek is waiting for my ProGuard tutorial for shrink APK. I'm not sure if I'm going to ever do a tutorial just on ProGuard. I apologize if I maybe said I would months ago or something. But yeah, I don't really... Well, we'll see. I'll think about it. Oh, that's something I could... That's a great... Thank you. That's a great question, Joshua. Okay, so let's just write this out here. That's a good question to end on. So, Joshua asks, what is Gradle? Why is there several different build.gradle files, settings, what's it called? Settings.gradle, etc. What does it do? What it do, man? All right, let's talk about that Gradle, man. So, higher end, yep. And hopefully you can, let me just do that in case my face is blocking part of the question. So let's talk about Gradle. I've never actually been asked about Gradle before, which actually surprises me now that I think of it. So let's start with the big picture. So, so when you're building, for example, it could be an Android application, or it could be a, excuse me, it could be an Android application, it could be a web application, it could be an iOS, doesn't matter. When you're building applications, most platforms, and by platforms I mean Android, iOS, or whatever, most platforms will have build tools. So what do these things kind of do at the high level? Basically, they do all of this. The thing is, they do an enormous amount of things. They do all these different really nitpicky things, which us as like app developers don't really want to worry about, and probably shouldn't when it comes development time. Now, if you're a real major nerd, and I mean that in the positive sense, if you're a real nerd, you might even want to try building an app without a build tool and just see what you have to do to build the whole software package architecture in your file explorer and write all the code in Notepad. But the thing is, like, when you make a new app, it needs specific directories and files. So that's the first thing that these build tools do, is they're going to help you build a lot of that stuff automatically. They're going to configure it for you. So that's sort of a build tool, and that's what Gradle is in the broader sense. Now, Gradle is really cool for a number of reasons. Number one, and this was their main goals, some of their main goals for the project, is that they wanted it to be very configurable. So if you want to be a real nerd and like really like I remember Kaushik Gopal from Fragmented podcast talking about how he had his Gradle thing like executing Ruby scripts. Or you'll see a whole bunch of different ways to sort of set up your build.gradle, your Gradle stuff. You can configure it, and if you want to be really technical about it, you can. However, so it's highly configurable, but also, this is the cool thing about Gradle, it has really great defaults. It makes very smart decisions about the sort of automatic stuff that you don't want to have to think about if you're under a deadline, or you just don't really want to worry about, you know, building the class path and all kinds of crap like that. So that's why Gradle's kind of neat. Now let's get into more of the implementation. So Gradle is a build tool, and it's very configurable, but it also has really good defaults, which is why it's my personal favorite build tool. So let's open up the build Gradle file for POS Trainer, which is one of my open source applications. Now, there are some people, as I said before, that like to go real technical with the Gradle stuff, and I would like to learn more myself, but I'm going to show you a slightly more complicated than average sort of Gradle setup. So there's two things I want you to think about. So why do we have multiple... Let me put it like this. So I want you to think of all these build Gradle files as configuration files. They do all kinds of things, but at the end of the day, what they do is you set this stuff and then it builds the files necessary based on your configuration or your scripts that you're running. They have all their own naming conventions, like build scripts and tasks and all this stuff, and I'll be perfectly honest, I read about it like 6 months ago. I've forgotten what all the things are called because I'm not good at remembering names, but each of these sort of lines of code in the Gradle, these little, I think these are called tasks. Maybe Darrell or someone else could verify this. This is either called a Gradle script or a task. And all you do is you just slap this groovy code in. I think it's groovy language. And then it's going to like generate scripts based on what you have in this stuff. And then it's going to execute those scripts at runtime, if I'm not mistaken. Blah, blah, blah. So these are configuration files. So when you're building applications, so to answer your question, why do we have multiple build Gradle files? As you get more and more complicated applications, you want to work towards different layers of your applications being almost like different modules. If you don't know what I mean by that, it's kind of difficult, but I want you to think like in a perfect decoupled architecture, like a clean architecture, which my friend Darrell has actually written an article on. And if you have it, post the link in the comments for that, Darrell, and I'll also post it on here. But this, for example, this app is clean architecture. And what you kind of want to move towards is, let's say we have like a module for the data, a module for the use cases, or the, yeah, I can't really explain that simply. Let's just keep it simple. Data, presentation, user interface, interactions, logic, data, in those two. So what we can do with Gradle is we can do two things. So the high-level build Gradle file, the one you find within your applications project, your main project file, which in this case is POS Trainer. I apologize, I can't zoom in here, but we've got the project level build Gradle file. So this project level Gradle file is going to contain configurations that you would like to be sort of globally accessible to the smaller modules of your app. So we've got the whole project, POS Trainer, and then we've got like the data module and the presentation or user interface module, whatever. And then we can have different build Gradle files for each little module. Why do you want to do that? It's start doing stuff like that. You'll start to see why you want to do that. It makes your files less verbose because you've split them up, and that's good. And it basically more closely follows the single responsibility principle, which I talked about in the first, I think that was episode 13, something like that. So the project level build Gradle file contains configurations that you sort of want accessible globally, or also it'll contain, so these are like the big repositories that you might want to add. So for example, if you want to be using, let's open up the room database thing here. So for example, if I want to use room database, or for example, view pager indicator or whatever, I need to add the high level repository URL to expose it to the sub build Gradle files. As you can see here, this thing says all projects. What it kind of means is like the whole project globally will now have access to these repositories. So if I were to, for example, remove this URL here in my app level build Gradle file, which is somewhere, which is right here, the lower level build Gradle file, it would no longer be able to call, where is it? This dependency here would be broken because it no longer has a repository which it can talk to. Now, another thing you can do with Gradle, actually let me sort of wrap that up. So the reason why we have multiple build Gradle files is because we're looking at a situation where we have a big project and then we've divided it into different modules. And let's say we have our data module. Should it have dependencies that it doesn't use? No. Like, should it have dependencies for view classes in your data modules build Gradle file? Absolutely not. That's a waste of code and brain. It's stupid. So that's the first thing. That's why we have multiple levels. Also, another thing, and this is what I'll kind of end on, that's really cool about Gradle, to get back to the extensibility of it, is in Gradle you can add all kinds of plugins. So for example, I won't fire it up because my computer would die if I'm streaming, but when I want to use, I could, like, for example, slap in a plugin. I believe, where would it go? Just trying to remember. It's been a long time, but I think, so the settings Gradle file, I believe you will list your different modules. So here I could list like here I could list like, I don't know, domain, front end, data. I'm trying to use simple language here, so if that sounds kind of funny. So you could sort of list your different modules, and then your top level file, you're going to list all the stuff that is required to be globally distributed. And then within your specific modules, you can apply these plugins. So there are all kinds of plugins. Like, let's say, for example, I wanted to use a Kotlin in this project. Then there's like a Kotlin called something like KAPT, or no, that would be the Kotlin annotation processor. But you can add these plugins, and the plugins will extend the functionality of Gradle. So if I slap in that Kotlin thing, then all of a sudden my application can now use Kotlin. And that's all going on behind the scenes. And generally speaking, all it takes is slapping in a couple lines of code. So what do these things do, just to wrap this whole thing up? Build tools allow you to slap in like short lines of code to do all of this configuration that some wonderful people have taken their time to write out, and you don't have to worry about any of that. So in a nutshell, that is Gradle, and hopefully I've managed to explain why we have different levels of build Gradle files. Ultimately speaking, they're just configuration files, and they are scoped. So scoped in the sense that we have an application, a project scope, and then we've got like a module scope, and and you can choose to structure your application like that. And as you get better and better as a developer, you'll want to start dividing things, in my humble opinion. So hopefully that answers your question about Gradle. And yep, yeah, well, I'll leave it open for, I'll stay on for just a couple minutes for some random banter, but I'm basically done with the Q&A stuff. And yeah, I feel like that was a pretty decent episode this time. I wasn't particularly happy about the past couple of episodes because In the previous episode, I didn't have time to do that, my demo for the whole dependency inversion thing. But also, I just was not feeling good. I didn't have enough time to sleep. I was dealing with the room database tutorial. And so I was not happy with the result of that episode. But today felt good. So looks like we don't have any more important stuff. So I will bid everyone a happy Sunday, or for some of you, it might even be Monday morning at like 12 a.m. But thank you so much for watching. Hopefully this random babbling was useful to you. And for those who are kind of just joining me, do me a favor, go check out my room database tutorial. If you would like to learn about model view, view model, live data, view model from Android architecture components, room persistence library, and how to build all of that stuff within the context of a full application. Not just a tiny little tutorial that gives you 15% of the picture in text. I build the stuff on camera. Thank you so much for watching. Peace out.